Today we will be presenting the Indinator, an AI-driven guessing game inspired by Akinator, but redesigned from scratch with our own decision tree engine, modern UI, and fully modular architecture. The goal of the Indinator is to create a system that adapts to the user over time, asks smarter questions, and improves its ability to correctly guess the chosen character or object. Right now we'll be doing an example of Harry Potter. The product demonstrates decision tree, Bayesian interference, React-based UI design, and a custom Python backend that handles reasoning and adaptive question selection. We built this system because we wanted to combine the machine learning with interactive gameplay. Most guessing engines rely on static decision trees, which don't improve over time. Our aim was to design a model that learns from each user interaction and updates its belief state dynamically. This product also helped us explore topics like probability updating, feature extraction, and decision tree reward design. If you are unfamiliar of the game concept of Akinator, it's basically like 20 questions, which can guess different characters from the list that you saw earlier. And as you can see, it correctly guessed Harry Potter. Next, we will do Sherlock Holmes as an example. And as you can see, it was able to correctly guess Sherlock Holmes as well. Next, we will do Naruto. So we're doing more examples with less yes, no, and more of like the probably not, to make it more like human-like. We do have like all the correct answers for these because we know these characters, but we are trying to show that like as people play the game, they might not know for certain. And it was still able to guess it correctly with a confidence of 80%.
As with any AI-related project, we need to talk about the data first. So we have three main data files. The first file here is the characters file, which has all the characters that are in the current database. Then we have the traits flat, which is basically all the traits mapped to each character. And then based off of these traits, we generate questions that are human readable, which are shown all in the questions.json. The main file starts here with the feature extractor, which basically makes a feature extraction from all those files. The initial thing it does is makes a feature matrix that has each row as one character and each column as one trait, and then it maps 1 or 0 whether or not that character has that trait. And then it basically uses that and makes a feature vector that is then used by the decision tree to make guesses. Speaking of the decision tree, this is the main decision tree engine. The decision tree engine here uses the scikit-learn decision tree classifier. It uses 5 main functions or methods, and they basically select the next best question. They update the state of the game. It gets the best guess, and then it has another function to basically dictate whether or not it should make a guess. Then we have obviously the reset, which basically sets the game to 0 again. In terms of the main method right here, we have is the decision tree right here, the init, and it gets all the data first and the training data, which then is then used for the game as you play it. It chooses an entropy-based question model for selecting the next best question, and then it uses Bayesian inference to map the probabilities based off of each question.
What up? So I'm going to explain the index TSX and the API server. So we're using Flask API for the Indinator web UI, and basically there's just a simple setup, simple little build state to make sure that it's all running and all working correctly for show. Then we'll go on the index TSX, and this is just front end for the whole website. We use just React and Vue to make it. And if you do cd front end npm run dev, and you also run python api underscore server.py, game should run smoothly. Yeah.